Welcome, Grade 7 students, to today's exciting lecture on the Earth's atmosphere. We'll embark on a journey to discover the fascinating world of the air that surrounds our planet.
Unit number 1, the Earth's atmosphere.
What is Earth's atmosphere? Earth's atmosphere is the layer of gases that surrounds our planet. It's like an invisible blanket that protects us and makes life on Earth possible. Composition of the atmosphere is mainly composed of nitrogen about 78% and oxygen about 21%. The remaining 1% includes gases like carbon dioxide, argon, and tiny traces of others. Layers of the atmosphere. Earth's atmosphere has different layers: the troposphere, stratosphere, mesosphere, thermosphere, and exosphere. Each layer has unique characteristics and plays a vital role in our environment. Troposphere. The troposphere is closest to the Earth's surface and where weather occurs. It contains the air we breathe and is where clouds form. Stratosphere contains the ozone layer, which absorbs harmful ultraviolet UV radiation from the sun. This layer protects us from sunburn and skin cancer.
Mesosphere is where meteors burn up as they enter Earth's atmosphere. It's the coldest layer and can reach temperatures as low as -90 Celsius, 130 F. Thermosphere. The thermosphere is where the International Space Station, ISS, orbits. Temperatures can be incredibly high here, but it would feel freezing because the air is so thin. Exosphere. The exosphere is the outermost layer and gradually merges with space. Satellites and space debris orbit in this layer.
Ozone depletion.
15 to 35 kilometers above Earth's surface, a gas called ozone surrounds the planet. The ozone layer acts as a barrier between Earth and ultraviolet radiation from the sun. However, pollution has caused the ozone layer to thin, exposing life on Earth to dangerous radiation. Earth's atmosphere is made up of 6 layers. The second layer, called the stratosphere, contains the ozone layer. The ozone layer is made up of a highly reactive molecule called ozone, which contains 3 oxygen atoms. Ozone is a trace gas in the atmosphere. There are only about 3 molecules for every 10 million molecules of air. But it does a very important job. The ozone layer acts as Earth's sunscreen, absorbing about 98% of damaging ultraviolet or UV light. But the ozone layer has gotten thinner. Chemicals called chlorofluorocarbons, or CFCs, are the primary culprits in ozone layer breakdown. A CFC is a molecule that contains the elements carbon, chlorine, and fluorine. CFCs are mostly found in refrigerants, aerosols, and plastic products. When CFCs are exposed to ultraviolet rays in the atmosphere, they break down into substances that include chlorine. The chlorine reacts with the oxygen atoms in ozone and rips apart the ozone molecule. Areas of damage in the ozone layer are often called ozone holes, but that name is misleading. Ozone layer damage is more like a thin patch, with the thinnest areas near the poles. The ozone layer above the Antarctic, in particular, has been impacted by pollution since the mid-1980s. There, the region's low temperatures speed up the conversion of CFCs to ozone-damaging chlorine. About 90% of CFCs currently in the atmosphere were emitted by industrialized countries in the Northern Hemisphere. In 1989, the Montreal Protocol banned the production of ozone-depleting substances. Since then, the amount of chlorine and other ozone-depleting elements in the atmosphere have been falling. Scientists estimate that chlorine levels will return to their natural state in about 50 years. By then, the Antarctic ozone hole will shrink to smaller than 8 million square miles.
Greenhouse effect and global warming.
Earth's atmosphere, which is a thin blanket of air surrounding the Earth from all sides. This air is a mixture of many different gases. Just like an umbrella which protects us from sun and rain, this thin layer of air protects Earth from the harmful radiations from the sun. But this stable temperature is rising every passing year. Oceans are getting warmer. Significant shift in the climate is seen. Glaciers are melting. Why is all this happening? What should be done to stop all this? We'll find the answer to all these questions through this session. Earth is constantly bombarded with enormous amount of radiations from the sun, which we receive in the form of light and heat energy. These radiations, in the form of visible, ultraviolet and infrared, have to first pass the Earth's atmosphere before reaching the surface. The ozone layer, which is present in the Earth's atmosphere, blocks some amount of harmful ultraviolet rays from reaching the surface. Of the remaining rays reaching the surface, part of it is absorbed by the Earth, and some, especially the infrared waves, are reflected back into the space. But some gases in the atmosphere traps this heat radiation and re-emits it to the surface, which leads to heating up of the environment. This exchange of incoming and outgoing radiation that warms the Earth is referred as the greenhouse effect. And the gases involved in this are called greenhouse gases, which mainly includes carbon dioxide, methane, water vapor, chlorofluorocarbons, etc. Friends, but are you not wondering why it is called greenhouse effect? Is it something to do with the greenhouse? If you said yes, you're thinking in the right way. A greenhouse is a glass building in which plants that require protection from cold weather are kept. The glass cover helps to trap all the heat energy and keeps the inside environment warm. Now consider our planet Earth. The atmosphere acts as the glass and traps the heat. The greenhouse effect is essential in order to keep our planet warm. In the absence of this effect, the temperature of the Earth's surface would have been -20 to -40 degrees Celsius. But too much of something is bad, right? If the plants in the greenhouse receives excess heat, it would burn. And if we consider planet Earth, over the last 2 centuries, human activities have changed the Earth's atmosphere in a dramatic way. The amount of greenhouse gases have increased and are still increasing. They trap too much heat. And this excessive greenhouse effect results in global warming, which is an increase in the Earth's average temperature. Consequences of global warming are enormous. Its effects are not limited to one country, but it would affect the entire planet. Knowing the fact that global warming exists and human-made carbon dioxide emissions have caused it, many nations of the world have come together to sign an international treaty, the Kyoto Protocol. The major objective of this protocol are commitment to reduce greenhouse gases by about 5% below their 1990 levels. But what can be done by us? How can we contribute in reducing global warming and also its consequences? Well, planting more number of trees, reducing waste generation, reducing the use of products which generate greenhouse gases, using energy efficient appliances, increasing the fuel efficiency of vehicles, using more renewable energy, or say switch into greener ways which causes less harm to our environment. That's all for today. I hope you found this session very informative and you got a thorough knowledge of what global warming is.
I hope you like our video.